E would be the right answer to a different question. What's the question? If it's a full sphere, then by symmetry, it would have to be, the center of mass would be in the middle, at the center of the sphere. We're using a symmetry argument to tell us that the answer has to be along the vertical line that passes through the center, because everything looks the same left and right compared to that line, forward and back in any direction, perpendicular to that line. So the question is, how far up should we go? The answer is, let's figure it out, and then we'll see how many of us got it right. So how can I carve this up so that I can figure it out? Think hard to yourself. See if you can't set up how you're going to carve up this shape in order to calculate the first moment. Remember, this is a hemisphere, not a semicircle. It's not a half disk, it's a half sphere.
Oh, that's awkward. That's awkward.
And I believe in the front row they're saying, awkward. Yeah. Do a bunch of disks that are horizontal. Do we agree that by symmetry, I only care about the z direction? Okay? So in order to get the first moment with respect to z, I'm going to have to integrate z dm. That part was easy. It's the dm part that's the problem. So I now need to figure out, how am I going to figure out what volume is inside the disk whose slice I'm indicating there? I guess I might want to have like a little, what would you call this distance? Like little r, the radius of the disk? If we had that, it would be a piece of cake. Would it? So dm is going to be, aha. Now it's not mass per unit area, it's mass per unit volume. I think you probably use the same thing in chemistry. What do you call it?
Rho.
Your boat. Yeah, rho times d volume. So the d volume bit, it's going to have an infinitesimal thickness dz, and then it's going to need the area of the disk. But the area, at least if I can use r, that's pretty straight ahead, right? So I need rho pi r squared dz. The problem is I need now to know what is r when it's a function of z. Any proposals? Gymnastics. What was that? So this part here, this side of the triangle would be the height z, right? And the other side of a triangle, which I could write like that, is r, what I'm trying to find. And what's this length, the hypotenuse of the triangle? That's the radius of the hemisphere. So can't I write that the radius of the hemisphere is squared is the sum z squared plus r squared by the Pythagorean theorem. So that means I now have a way of expressing r squared that only relies on z and a constant. That's good. So I can rewrite dm is the mass density rho pi. Yeah, it's because rho is not a function of position that I'm treating it as a constant. Now to get r squared, I just have to subtract z squared from both sides. So, holler now if that doesn't make sense to you. Okay, so we're pretty close to done. To do the first moment, having expressed dm in terms of geometry, which was all of this junk, times the mass density, I can calculate the first moment. And that would be the integral. What limits do you propose?
0 to the top, whatever, 0 to r.
0 is the smallest value of z I care about, and the biggest value of z is capital R, rho, z dm. So z times dm, rho pi r squared minus z squared dz. Cool? So because rho, in this problem, rho is a constant. It doesn't care about the position inside the hemisphere, so I can pull that out of the integral, rho pi. So I'm left to integrate zr squared minus z cubed dz between 0 and capital R. Again, that's in the class of integrals we can do. You can probably do it. Remember, you're supposed to be ahead of me, so you should be doing that. So hopefully is that what you got? Okay, and by the time we substitute in capital R, the lower limit's easy. The capital R, we're going to get r to the 4th over 2 minus r to the 4th over 4. So that's a quarter r to the 4th. So we have rho pi over 4 r to the 4th. Okay, now, what do I need? Does this pass the sniff test? At this point, I could have screwed it up. What am I checking again? Dimensions. Does it have satisfactory dimensions? What dimensions does it have? What are the dimensions of rho? Mass over volume. So what are the dimensions of the first moment? Mass over volume times length to the 4th, which is like the length times the volume. So yeah, mass times length, that's socially responsible. Okay, and what about, let's be clever, how about the mass? What's the mass? I don't want to do another integral. Yeah, what's the volume of a hemisphere? Okay, 2/3 pi r cubed. That's the volume of half a sphere. So the position of the center of mass, which is the first moment divided by all the mass, must be rho pi over 4 r to the 4th over 2/3 rho, or rho times 2/3 pi r cubed. All right, the pi's go out. That looks a lot like 3/8 R also passes the sniff test for dimensions. 3/8 of the way up. 3/8. So what do you think? So halfway up, it's about A.
No, halfway up.
Correct answer here is B. B. Surprised? 3/8 of the way up.